Hey everybody, it's Mr. Carr again. Today we're going to be looking at 3.4. We're going to be proving triangles are congruent. Now, before we talked about what does it mean to be congruent. It has to have all these matching sides and angles. But today we're going to be looking at shortcuts in terms of how do we identify that two things are congruent, specifically triangles. How do we know for a fact that two triangles are congruent? Our first one is going to be what's called side-side-side congruence. We do a shorthand of that as SSS. So if three sides, do this highlighting, if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So when I look at this diagram, since we have this is congruent to that, that's congruent to that, and then that's congruent to that. We have three pairs of sides that are congruent. That means that triangle ABC is congruent to triangle RST due to side, side, side. So when we look at that, we're just trying to find it in our diagrams here. In the first case, decide if there's enough information to use SSS. There is. I've got 9 matching to 9, 8 matching to 8, but we got to remember the reflexive side. LK is congruent to LK due to reflexive. So what I do have is 3 pairs of sides that are congruent, so that means yes, we have side, side, side. Here in the next one, we got this one matching to that one, and that matches to that, but we don't know anything about those pairs of sides. 2 pairs of sides is not enough, so we have not enough info. Okay. The next reason, so reason number 2 is what's called hypotenuse leg. If the hypotenuse and leg of a right triangle, very important, that's a right triangle, are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So in this scenario, since A and angle D are right angles, making these both right triangles, here we have the hypotenuse and the hypotenuse matching up, and we have a leg and a leg matching up. My conclusion is that triangle ABC is congruent to triangle DEF due to hypotenuse leg. That's how I know this. So when I look at my examples here, first thing I'm going to look for when I'm testing hypotenuse leg, do I have right triangles? So in this first case, yes, I do, because I have this and this. So since I have a right triangle here and here, now I want to look for, do I have matching hypotenuses and do I have matching legs? I do have matching hypotenuses, that's there and there across the 90 degrees. And again, just like one of the early examples, this is my reflexive side. BC is congruent to BC from reflexive property. So what that means is this is yes, they are congruent because of hypotenuse leg. So I can make the statement that triangle ABC is congruent to triangle DCB. Okay. For the next one, we have right triangles, so it passes that level. We do have matching hypotenuses because they're being shared, so they're reflexive. But I don't have any other information. I don't have any information about these sides or these sides. So that means that it's no hypotenuse leg because there's not enough info here. Okay, not enough info. And for my last example, we do have right triangles again. We do actually have hypotenuses that match up because if I do a Pythagorean theorem, this is a triple. This is going to come out to 5. So 3 squared plus 4 squared equals 5 squared. It's a Pythagorean triple. So we have the 5. So we do have matching hypotenuses, but again, we don't have matching legs. We need to know if one of these pairs of sides, one of these other sides are 3 or 4. So again, it's no hypotenuse leg because there's not enough info. Okay. We're on to our last few of these. Next example of why two triangles are going to be congruent is what's called side angle side. If two sides and the included angle, this is an important word here, the included angle of one triangle are congruent to the two sides and the included angle of a second triangle, and the two triangles are congruent. So included kind of means in between. So when I look at this diagram, angle R and angle U are included because we're working with these sides that are congruent here and here. So because our included angles and our pair of sides here and a pair of sides here are congruent to each other, that means that triangle RST is congruent to triangle UVW due to side angle side. Okay, so let's take a look at that here in these diagrams. This one is pretty straightforward. We have our angles here that they are included because of the way that the diagrams draw that way and that way. Then we have a pair of sides here and a pair of sides here. So I'm going to label this with my SAS and look, is my angle between my two pairs of sides? Yes, they are. So yes, side angle side. Okay, for the next one, just as always, we double check, hey, we got reflexive side there. This one almost looks like it, but it's not quite. Because again, these are two pairs of sides, and then here's a second pair of sides here. And here is technically an angle, because right angles have to be congruent to themselves. But I don't have A showing up included. This is the included angles in terms of my sides. So I cannot use side angle side. But since that is matching up to like this diagram, I do know that I could use hypotenuse leg. So it's no side angle side, but it is hypotenuse leg. Okay. So they are congruent, just not for the side angle side reason. And my last example, so they're actually kind of related to each other. Angle side angle and angle side. Angle side angle is when two angles and the included side, so now we're talking about sides being included, are congruent to two angles at the included side of a second triangle, then the two triangles are congruent. So included is those two sides there because they're in between my sets of angles. So I have a pair of angles here, a second pair of angles there, and my included sides. So I can say that triangle ABC is congruent to triangle DEF because of angle side angle. Okay, next one, similar idea, but now we don't have to have the included. Okay, if two angles at the non-included side of a triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So here's my angles that match up here and here. And then my sides are right here. So it's angle, angle, side in this case. So triangle ABC is congruent to triangle DEF here due to angle, angle, side. You can almost use them back and forth interchangeably. You just need to make sure you understand which one's which in this case. So it just look at where the side is compared to the two angles. Is it in between or is it not in between? So when I look at the next one, the first thing I'm noticing is, and it's important to kind of look at this one. It says identify the congruence postulate. So here are my 5 postulates: side, 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 hypotenuse leg, side angle side, angle side angle, and angle angle side. Now that we have all 5 of those, we're going to be able to choose which one makes the most sense in a given thing. The one thing I want to point out is every single thing has at least one pair of sides that are congruent. So when I look at diagram A, we have no sides. We have angles here and here, but there's no sides. So these are not congruent. We need at least one pair of sides. For the next one, we have a pair of angles here and here. And again, we have our reflexive side. So because of that, that would be angle, angle, and the non-included side. Angle, angle, and non-included side. So that's going to be yes due to angle, angle, side. Next one, again, the other thing it's not an assumption. We know for a fact that vertical angles are congruent to each other. So I have a pair of angles here and a pair of angles here in the middle. Then I got my sides that are included. So this one is also a yes due to angle, side, angle. So when you work through these diagrams, you're looking for which of the 5 match up. And that is actually it for today. Our whole goal is to find when our two triangles are congruent. It needs to match up to one of these 5 postulates: side, 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 hypotenuse leg, side, angle, side, angle, and angle, side. That's it for today. Take care, everyone.